Now we are going to study the concept of pseudo force. This is a very important concept for qualitative analysis of situations when seen by an accelerating observer. To understand pseudo force, we take up a practical illustration. We just talk about a practical illustration in which, say, on horizontal ground there is a plank. So there is a smooth surface, smooth horizontal ground on which there is a plank and a boy is standing over it, which is fixed on the plank, and so the mass of this plank is 20 kg. And we have placed another block of mass 5 kg over this plank, and again there is no friction between the block and the plank. Now, if we start applying a force of 40 Newton onto the plank, we all know what is going to happen. If 40 Newton force is applied on the plank, say we ignore the mass of boy, or if we include the mass of boy in this 20 kg, this system of boy plus plank will start accelerating toward right. And the acceleration of this plank as well as this boy who is at rest on plank can be written as 40 by 20, it is 2 meters per second square. And as this block is at rest and there is no friction, we can simply state this will remain at rest and this plank will slide below this 5 kg block. So in this situation, we can say this 5 kg block will be at rest and the boy plus plank system will move toward right at an acceleration 2 meters per second square. Now in this situation, if we just look at this 5 kg block from the point of view of this boy, if this boy will have a look on this 5 kg block, he'll feel that I am at rest because with respect to himself, his reference frame is always at rest. So he'll just have a look on this 5 kg block and realize that this 5 kg block is moving toward left at 2 meters per second square. Whereas by an ground observer, it can be stated that 5 kg is at rest and this system is moving toward right at 2 meters per second square. But yourself, I would like you to suggest that yourself you should feel that you are standing here and you are looking onto this block of 5 kg. So you'll feel that this 5 kg is moving toward left with an acceleration of 2 meters per second square. So with respect to this boy, if we draw the free body diagram of this 5 kg block, we can simply state free body diagram of 5 kg block with respect to boy on plank. If we just have a look on this 5 kg block from the point of view of this boy, we can simply state it is not experiencing any force but it is accelerating toward left at 2 meters per second square and it is of mass 5 kg. You'll be surprised to see without any force the block is accelerating toward left. So you can simply declare that it will be experiencing a force according to Newton's second law, that is mass into acceleration. Its mass is 5 kg and acceleration is 2 meters per second square. We'll say a force of 10 Newton is acting on this 5 kg block which is providing an acceleration of 2 meters per second square. But this is not an actual force. You can simply state this is not an actual force, this only appear to be acting on this 5 kg block because this block is appear to be accelerating with respect to an observer who is accelerating along with the reference frame. This particular force, which is not an actual force, we call pseudo force. So you can see pseudo force is a force which appear to act on a body when it is seen by an accelerating observer. This is a very important point to understand. Let's write it down also. First, we'll write down a note for the pseudo force where we can simply write that pseudo force appear to act on a body when seen by an accelerating observer. Because if an observer is accelerating, he'll feel that other objects in its surrounding which are at rest will appear to accelerate in opposite direction. So we can simply state, if this is the situation, there is a body of mass m at rest. It is seen by someone, say, who is on a skateboard, and he is accelerating forward with an acceleration a. So this observer, we can simply state, this observer will feel that I am at rest and this object is accelerating in backward direction with an acceleration a. So we can say, to this observer, a pseudo force appear to act on mass m, and this pseudo force will be mass of this object multiplied by the acceleration, which is actually the acceleration of observer. It is not the actual acceleration of this mass. Actually, if we talk in terms of an observer who is on ground, this block is at rest. So we can simply state, in this situation, pseudo force can be written as mass of body or mass of object multiplied by acceleration of observer. And we can simply state also that direction of pseudo force is opposite to the direction of acceleration of observer. So these are the two things you need to keep in mind. One is the pseudo force is mass of object into acceleration of observer, who is just doing analysis or observing the object, and the direction of pseudo force is opposite to the direction of acceleration of observer. So keep these two things in your mind. We'll discuss more applications based on pseudo force. Another important fact about pseudo force is pseudo force does not obey Newton's laws. As we have studied, all forces follow Newton's laws, but pseudo force is an exception because it is not a real force. It is not an actual force. It is a force which appears to be acting on a body when it is observed by an accelerating observer. Let us analyze how Newton's laws are violated by pseudo forces. Say if on a ground there is an object, or say there is a block of mass m which is kept at rest, and in parallel say there is an observer on a skateboard who is also at rest. It is of say mass m, and a force is applied on it at some instant. So we can say this observer will start accelerating with an acceleration a1, that is f by capital M. So if he is continuously looking onto the block, we can say that when this observer was at rest, he'll feel that the block was also at rest. But as soon as it starts accelerating, he'll feel that the block started accelerating in backward direction with an acceleration a1. But there is no external force applied on this block. So we can simply state the first law of inertia is not valid, because without force, block started accelerating. Here we can see, as seen by this observer, he'll feel that without any force from rest, at once it started accelerating with an acceleration a1. So Newton's first law is not valid. If we again think on the second law, which is law of unbalanced forces, which says sum of all forces acting on the object is mass into acceleration. Here you can see, as no force is acting on it, but still it is continuously accelerating. So we can say this is also not valid, as without force, mass is accelerating. Third law, if we talk about action reaction, we can simply state, even if we consider a hypothetical forces acting on it that we define as pseudo force, because of which it is accelerating, this third law is violated, as no reaction exists for pseudo force, because reaction exists only for a realistic force. If a body applies a force on another body, then the second body will react the first body with the same force. Here there is no external agent who is applying a real force. Pseudo force is just a virtual force which appear to be acting on the object which is seen by this observer. So there will not be any reaction of the pseudo force. It will be a singular force which does not obey Newton's third law also, that is action and reaction. So based on this concept, as Newton's laws are not valid in the reference frame of this observer, we can say the reference frames through which when we observe different type of object and their motion, these must be classified in different categories. One category would be the one in which the observers are not accelerating, and other category is the one in which observers are accelerating. These are defined in two ways. You can also write down one point which is also very useful for us. A note: based on acceleration of observer, reference frames are classified in two categories. These are, first one we define as inertial reference frames. These are the reference frame in which acceleration of observer is equals to 0. The second are non-inertial reference frame. These are the reference frame in which acceleration of observer is non-zero. If an observer accelerates, then obviously the observer will feel that a pseudo force is acting on it. So always in non-inertial reference frame, we analyze some object, we must consider pseudo forces. But when we talk about inertial reference frame, when our reference frame are not accelerating, which are in uniform motion, or we can also call them to be at rest. If they are at rest or in uniform motion, there is no evidence of pseudo forces seen in such reference frame. These are called inertial reference frame. Now we are going to discuss about these reference frames in detail. Now we'll write something about inertial and non-inertial reference frames. As we have just now discussed, inertial reference frames are those which are at rest or in uniform motion. We can also say in inertial reference frames, all Newton's laws are directly applicable. In majority of reference frame, we can say all are inertial reference frame if they are at rest or in uniform motion. We can directly apply all Newton's laws. But when we talk about non-inertial reference frame, we can say the reference frames which have some non-zero acceleration are called non-inertial reference frames. And in these frames, Newton's laws are not directly applicable. Because we have studied that if some acceleration is there in the reference frame, we can say the observer in such frames sees a pseudo force on all objects in direction opposite to reference frame acceleration. And due to the pseudo force only, we can say that Newton's laws are not directly applicable. So this is the basic difference between inertial reference frames and non-inertial reference frame. Inertial reference frames are those reference frame in which observer are either at rest or in uniform motion, and non-inertial frames are those which have some non-zero acceleration. And if an observer is having non-zero acceleration, we already studied that such observer sees or feels that a pseudo force in opposite direction is acting on the object. Once again, we can write the value of pseudo force, which we have discussed in earlier slide also. Pseudo force is mass of body multiplied by acceleration of reference frame or acceleration of observer. This is the way how we analyze.